Hello everybody. Okay, so in this video we are going to be looking at the unit circle. So hopefully this is a nice short little introduction to the unit circle. So what is a unit circle? I'm so glad you asked. So a unit circle basically is a circle that has a radius of 1 unit, or a radius of 1. So this circle here, I crudely drawn on a coordinated plane, has a radius of 1. So, presuming that this circle starts at point 0, 0, let's identify some points on this circle. So, I know here, my point is going to be 1, 0, because my radius is 1, remember this, so I'm 1 to the right, and I haven't gone up any. Here, my point is going to be 0, 1. Here, my point is going to be minus 1, 0. And then finally, here at the bottom, my point is going to be 0, minus 1. So they are 4 key points now on my unit circle. So what is important about a unit circle? Well, first of all, let's talk about measuring angles within a circle, right? So when we're measuring angles within a circle, we usually start from the positive x-axis. So from here. So we usually start our measurement from there, and then we go towards the left. We kind of go counterclockwise. So for example, the angle I make here, I'm going to call theta, right? That's going to be a positive value here. So we are going towards counterclockwise. So what's that mean? So we know, then just looking for my circle here and from our understanding of geometry, in the first quadrant here, so this is my first quadrant. So I'm denoting that with a 1, or a Roman numeral 1. This is my first quadrant. So in my first quadrant, contains 0 to 90 degrees. In my second quadrant, it contains degrees from 90 to 180. So 90 to 180. Here is from 0 to 90. In my third quadrant, it contains the degrees from 180 to 270. And then finally, in my fourth quadrant, it contains the angles 270 to 360. So you're probably thinking, whoop-de-doo, that's fine. What's that got to do with anything? I'm so glad you asked. Well, we can apply the special property to the unit circle. So let's just look at this blue line I have here now. Let me draw a point here. I'm going to draw a point here. And I'm going to label that point X, Y. So I have a point X, Y on my circle. So a coordinate X, Y on my circle. Let's see if I can rewrite X and Y as something else. So what I'm going to do is I'm going to bring this line down here. And I'm going to make a right angle. So let's label our sides here, right? So I know my hypotenuse here is going to be 1. Yeah? It's going to be 1. Why is it going to be 1? Because it's my radius. Yeah, it's coming from the center to the edge of the circle here. So it's going to be 1. So my hypotenuse is going to be 1. But what are the other two sides going to be? So let's label this orange just to switch things up a bit, yeah? So what's the length of the orange side and what's the length of the black side? Let's think for a moment. Let's put our thinking caps on, ladies and gentlemen. Let's put our thinking caps on. Well, it's not really a thinking cap. It's a Canadian takeout cap, but you get the point. Let's put our thinking caps on here. Well, I know from coordinate geometry, yeah, this point here is going to be Y above the x-axis. So the length of this point is going to be Y. And I know this line here is going to be X units away from the Y-axis. So this side of my right angle triangle is going to be X. So, whoop-de-doo, what does it all mean? Well, let's isolate that right angle triangle for a moment. So, I'm going to isolate this triangle here. So, it's angle theta. It's a right angle triangle. I have a hypotenuse of 1. My opposite is equal to y. And my x is going to be equal, my adjacent is going to be equal to x. So let's look at our handy dandy trig ratios, right? So let's think of our trig ratios. So, oh hell, another error of algebra. So I have sine theta is going to be equal to my opposite over my hypotenuse, which is going to be y over 1. We know anything divided by 1 is itself. So I have sine theta is equal to y. Ooh. Right, let's try another one. Cos theta. Well, on this triangle, this is my adjacent. This is my hypotenuse. Right, so my cos theta is going to be x over 1. And again, anything divided by 1 is itself. So cos theta is going to be equal to x. Well, I now have made an expression for my x and y coordinates. So now, instead of saying x and y for my coordinates, I can now make a point. I can find a point at any degree within my unit circle, right? So my new coordinates now are going to be cos theta and sine theta. Cos theta being my x coordinate and sine theta being my y coordinate. So let's test out this hypothesis. So I'm going to test out this point here, over here, the minus 1, 0. I know at this point here, my angle is going to equal 180 degrees because it's on a flat line. So let's test out this hypothesis. So I have cos 180 and sine 180. Well, if you put them into your calculator, cos 180 is going to be equal to minus 1 and sine 180 is going to be equal to 0. So my xy coordinates, when my degree is equal to 180 degrees, is going to be minus 1, 0, which I've just proven right by and below. So on my unit circle, my x and y coordinates are given by cos theta and sine theta, or how many degrees it has rotated away from the positive x-axis. So that's interesting. And then we can develop one cool little property from this. So in a previous video I did there on the equation of a circle. So we know if a circle starts at point 0, 0, the equation of a circle is given like this. X squared plus y squared is equal to 1. Or sorry, I should say radius squared. Well, let's sub in my properties here. Well, I know my x coordinates now are going to be given by cosine theta squared plus, and then my y coordinates is given by my sine theta squared, and the radius of my unit circle is going to be 1. So I have now cos squared theta plus sine squared theta is going to be equal to 1 squared, which is 1. And this is a key trigonometric property that you need to know for your Leaving Cert exam. So if I have an angle and I find the cosine of the angle and square it and add it to the square of the sine of that same angle, I will always get 1. Always. So it could be cos 185 squared plus sine 185 squared. I'm going to get 1. And that is our unit circle there. So let's do some little housekeeping now on this. So in my unit circle here, I have my 4 quadrants like I mentioned. So in my unit circle, I'm just going to draw a very crude circle here. That's a bit too crude, I think. Let's whip out the ding dong. Nope. Bing, bang, bong. Sing, sang, song. Close enough, right? So, I have my unit circle here. So, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Well, we know from geometry anyway, in quadrant 1, my x values are positive and my y values are positive, correct? Because, looky here, I'm going from here to here, where this is all positive x-axis, and from here to here is all the positive y-axis. It's going on the positive y-axis. Therefore, my x values are always going to be positive, and my y values are always going to be positive. So, therefore, cosine is positive, and sine is going to be positive. So if I sine or cosine an angle from 0 to 90 degrees, I'll always get a positive answer. What about tan, though? What happened to tan? What happened to tan? Right? Well, tan, as you were, ladies and gentlemen, is written as opposite over adjacent. Remember, cosine is written as adjacent over hypotenuse. And sine is written as opposite over hypotenuse. What would happen now if I divided sine by cos? I have opposite over my hypotenuse all over adjacent over my hypotenuse. When you divide a fraction by fraction, you flip it and multiply it. So opposite over hypotenuse times the hypotenuse over the adjacent. My hypotenuse is going to cancel, and I'm going to be left with my opposite over my adjacent, which is my tan ratio. So if I ever divide sine of an angle by the cosine of the angle, I will always get the tan of the angle. So that's why here, if I divide sine by cos, well, positive divided by positive is going to give me positive. So tan is going to be positive in the first quadrant. Gorge. So they are all positive in the first quadrant. Let's look at the second quadrant now. My y values are still positive because it lies above the y-axis. So my y values are positive. So y is positive. Therefore, sine is positive. So sine of any angle between 90 and 180 is going to be positive. But what about cos? Well, now I'm entering the negative territory on my x-axis. So x, my x-coordinate, or my cosine of the angle is going to be negative. So therefore, cosine of angles between 90 and 180 are going to be negative. Now, what about tan? Well, sine divided by cos. Well, a positive number divided by a negative number is going to give me negative. So therefore, tan of my angle is going to be negative in the second quadrant. So tan of an angle between 90 and 180 is going to give me a negative value. Then same again in the third quadrant. Now in the third quadrant, both my x coordinates and my y coordinates are negative. But what about tan? Right, so that's my cosine, sine. So what about tan though? Well, negative divided by negative gives me a positive. Therefore, tan is positive. Right, I should say sine is positive here. So in my first quadrant, they're all positive. In my second quadrant, only sine is positive. In my third quadrant, only tan is positive. And then what about my fourth quadrant? Well, again, I've done a rotation, so my y values are still negative. So if my y is still negative, therefore my sine of theta is negative. So sine of an angle between 270 and 360 is going to be negative. My x is going to be positive because, again, I've moved back over to the positive side of my x-axis. So therefore, cosine is positive. And again, tan, well, negative divided by a positive is going to be a negative. So therefore, tan is going to be negative. So only cosine is positive in the fourth quadrant. Or to note that was C. So that is a very important property to learn about now. So that is called our cast circle. So all are positive in the first quadrant. Sine is positive in the second quadrant. Tan is positive in the third quadrant. And only cos is positive in the fourth quadrant. So what people need to remember is to remember cast, so C-A-S-T. For me, I don't like it that much. I prefer Sex and the City. So Sex and the City, right? Sex and the City snaps off. You know what I mean? So Sex and the City. It's a very famous TV show with Carrie Bradshaw. As I prepare for World War III, maybe I should be thinking about World War Me. You know what I mean? So Sex and the City. So that's how I remember where my trig ratios are positive. So Sex and the City, 1, 2, 3, 4. All positive in first quadrants. Sine is positive in the second quadrant. Only tan is positive in the third quadrant, and only cosine is positive in the fourth quadrant. And this information is very important for my next video when we're solving trig equations. And with that, ladies and gentlemen, I hope you enjoyed it, and I shall peace out. Bye.